Hello everyone. Today we are going to discuss some of the numerical problems of gaseous state. So some important numerical problems up to ideal gas equation. So based on gas laws and ideal gas equation. Some of the important numerical problems. Okay. See, yesterday some of the students asked me some doubts. Okay. So one of the questions is that oxygen is present in 1 liter flask. Oxygen is present in 1 liter flask at a pressure of 7.6 into 10 power minus 10 millimeter of mercury. Millimeter of mercury. Is that clear, ma? So here, what is asked here? Which gas is mentioned here? O2 gas is mentioned. Oxygen gas is mentioned. It is present in how many liters here? 1 liter. So volume V is equal to 1 liter here. Volume is 1 liter. And how much pressure is given here? Pressure of the gas is given 7.6 into 10 power minus 10 millimeter of mercury. So this one we have to convert into ATM. How to convert millimeter into ATM? Generally 760 mm is equal to 1 ATM we know. Then these many mm is equal how much? Okay. So then what here? 7.6. Okay. So we have to take here. So it is pressure here. So pressure should be converted into what, ma? Pressure should be converted into ATMs here. And it here volume is given what now? 1 liter here. So volume is given 1 liter. Pressure is given in mm. So we have to convert the millimeter into what? ATM. Okay, by 760 we have to. 760 we have to. Okay. So then calculate the number of moles of oxygen. N is equal to what? So what they ask here? Small n. Small n means what? Number of moles is equal to what? So this number of moles we have to calculate. So what are given here to you? You are given with volume, pressure, and temperature is given here. So temperature is given what? Degrees Celsius. Centigrade temperature given here. We have to convert into Kelvin temperature. So 0 plus 273. 0 plus 273 Kelvin. So here 0 plus 273, 273 Kelvin temperature given. 1 liter volume is given. And pressure is given millimeters. We have to convert into ATM. So we know that 760 mm is equal to 1 ATM we know. Then 7.6 into 10 power minus 10 mm equals to how much? So 7.6 into 10 power minus 10 by 760 will be equal to what now here? That what the pressure. Okay. So pressure in ATM we have to take. And what is the formula now here? PV is equal nRT. PV is equal to nRT. From that N is equal to what now? N is equal to PV by RT. PV by RT. So P into V by RT. R is what here? Universal gas constant. So PV by RT we have to take here. PV by RT. Tell me now what is P value here? P value in ATM we have to take. Volume in liters we have to take. R in 0.0821 liters atmosphere. Liter atmosphere we have to take R value. R value in liter atmosphere how much? 0.0821 into temperature in Kelvin we have to take 273 Kelvin we have to take 273 Kelvin. So in that way we have to use formula what? N is equal to number of moles equals to PV by RT. So pressure is given in mm, we have to convert into ATM, and volume is given in liters. Same 1 liter you take, and temperature is given 273 Kelvin, and we have to calculate what? N value by knowing what? R value. R value will not be given here. R value you must remember. Then we get what now here? Approximately some answer here. So calculation part we have to do. Okay. Now next one, the total weight of a gaseous mixture. Okay, which contains 11.2 liters of CO2. First one, what is given? CO2 gas. 11.2 liters of CO2 gas given. Then 5.6 liters of O2 given. Now they're asking what your weight. Weight means mass. Mass they're asking. So we know that 22.4 liters equals to 22.4 liters of CO2 equals to 22 means what? 44 grams. 22.4 liters of CO2 is equal to 44 grams. Then 11.2 liters of CO2 will be equal to how many grams? That way we have to take. And here also 5.6 liters of O2 weight we have to get. We know that 22.4 liters equals to gram molecular weight. 22.4 liters of oxygen is equal to gram molecular weight of oxygen. That means 22.4 liters equals to 32 grams. Then 5.6 liters equals to how many grams? Like this weight we have to take. Then 22.4 liters of N2 gas, 44.8 liters of another gas. So these are different gases are given. Helium gas. So helium, nitrogen, oxygen, CO2, different gases given. The weight of all these gases we have to say total weight. And what is temperature given here? 0 degrees Celsius means 273 Kelvin, and 760 mm means 1 atm. 760 mm indicates what? 1 atm. 1 atm pressure and 273 Kelvin temperature given. So STP they give, STP condition. At STP, we know that 22.4 liters equals to gram molecular weight. 22.4 liters of any gas. Any gas means it may be CO2 or O2 or N2 or helium, anything. Any gas of 22.4 liters will have how much mass? Its gram molecular weight. Okay, then given volume will have how much weight we have to calculate. Okay, so this way you take like this here. So for CO2, 22.4 liters at STP. So at what conditions we have to take here? STP conditions. Already they gave STP conditions only. Temperature is given 0 degrees Celsius and the pressure is given 1 atm, 760 mm they give. At STP, 22.4 liters of CO2 will have how much weight? 44 grams, gram molecular weight. And 11.2 liters will have how much? That is 22 grams. So this weight we have to consider. Next, for oxygen gas also, 22.4 liters of oxygen will have gram molecular weight, 32 grams. Then 5.6 liters of oxygen given there. It will be equal to what now? 8 grams. Then 22.4 liters of nitrogen is equal to 28 grams, gram molecular weight of nitrogen, 28. And for 44.8 liters of helium. Generally, we know that 22.4 liters of helium equals to gram molecular weight of helium, 4 grams. Then 44.8 liters equals to 8 grams. So we have to add all these weights. Now 22 plus 8 plus 28 plus 8 will be equal to 68 grams. So 68 grams is what now here? The total weight of all these gases. Next, another examples. The previous two problems are asked by some students. Yesterday's doubts. Okay. Next, example 1. A sample of gas occupies 10 liters. Immediately, whenever the numerical value given here in the problem, we have to underline that, and whether it is volume or pressure or temperature, what is that given, we have to underline first. So 10 liters, liters means what volume it is. So volume is given. A sample of gas occupies what? 10 liters of volume under a pressure of 1 atm. So what is given? Underline 1 atm, 1 atmosphere. So what is given here? P is given. So pressure is given and also volume is given. Okay, so what will be its volume? What will be its volume? So this volume, again volume is asked means what? It will be initial volume. Suppose it is what? Initial volume V1 is given 10 liters and V2 will be what? V2, what will be the volume of the gas? So V2 will be to be calculated, means is to be calculated here. So V2 we have to calculate here, and P1 is given here. P1 is given 1 atm pressure. At 1 atm pressure, the volume V1 is 10 liters. Then what will be V2 if the pressure is increased to 2? Here increase it to, they ask here, increase it to 2 atmosphere. So P2 should be what now here? P2 should be equal to what? P2 should be equal to 2 atm. P2 should be equals to 2 atm we have to take here. Now here one important thing what we have to understand is that sometimes they give you the pressure is increased by 2 atmospheres. Increased by, if they give you, suppose if they give you by 2 atmospheres, initial 1 atmosphere plus this 2 atmosphere we have to take final pressure. If they say that increased by 2 atmosphere, suppose 1 atmosphere initial P1 value plus this 2 atmospheres added. Okay, increased by means 1 plus 2, 3 atm we have to take P2. But here they said that initially pressure was 1 atm and the pressure P1 is increased up to 2 atmospheres. 2 atmospheres means what now here? P2 should be taken, this value given. PO2 is given means the same thing, whatever is given we have to take. If they give increased by means what we have to do? This 2 should be added to 1. Then P2 should be 3. But here increased 2 they give. That's why P2 should be taken as 2 atmospheres. When pressure is 2 atmospheres, what will be volume? What will be volume we have to get? What will be volume we have to understand here? Is that clear, ma'am? And now assume that the temperature of the gas sample does not change. That means T1 is equal to T2. So T1 value, initial temperature is equal to what? Final temperature. So T1, T2 both are same here. But what is changing here? Pressure is changing, volume is changing. So what is this law according to? According to these given conditions, what law is used here? Boyle's law is applied here. Boyle's law generally given by what now? P1 V1 is equal to P2 V2. P1 V1 is equal to P2 V2 at constant temperature. So now see here, V1 is given, V2 is to be calculated. P1 is given, P2 is given. Applying Boyle's law, P1 V1 is equal to P2 V2. Now what we need to calculate? The V2 value we have to calculate. So V2 is equal to what now? P1 V1 by P2. So P1 how much now? 1 atmosphere into V1 how many liters? 10 liters by P2 is 2 atmospheres. That equals to 10 by 2, 5 liters. So 5 liters will be what now? Volume. So when pressure was 1 atm, the volume was 10 liters. When pressure is increased up to 2 atmospheres, the volume decreases to 5 liters. Like this, final volume we have to calculate. Next, example 2 problem. Okay, a sample of a gas occupies 600 ml. Whenever the value is given, that value underline first. What is this here? Volume or pressure? It is volume. So 600 ml volume is given. At what temperature given here? 27 degrees Celsius. Now what is this here? We have to take Kelvin temperature or centigrade temperature in this case. Always we have to take what? Temperature in Kelvin scale. On Kelvin scale we have to take here. Okay, so Kelvin temperature is equal to what, ma? Centigrade temperature plus 273. So 273 plus 27 how much? 273 plus 7 how much? 280. 280 plus 20 how much? 300. So what is the temperature given here? So 300 Kelvin given. So 300 Kelvin is the temperature on absolute scale. That is Kelvin temperature. Okay. So Kelvin temperature only we have to take here. Remember. So temperature is given, volume is given. But volume is given liters or ml. It is given milliliters. We have to take in what? Liters. Okay. So milli means how much? 10 power minus 3. Milli indicates what? 10 power minus 3. If the answer is, if options are given in ml, suppose, if options are given in ml, you take ml only here. V1 also take ml only. But if options are given in liters, we have to convert into liters this time. So temperature is given, volume is given. And at 1 atm. So pressure is given what, ma? Pressure is given 1 atm. So pressure is given 1 atm. Temperature is given 27 degrees Celsius. And the volume is given what? 600 ml. So now these three are given to you. What will be the volume? What will be the volume means V2 we have to calculate. V2 is to be calculated. So V2 is what? So V2 we have to calculate and V is given here. Is that clear, ma? At 127 degrees Celsius. What is T2 here? T2 is equal to 127 plus 273. T2 is equal to 127 plus 273 Kelvin. So T2 is given. V2 we have to calculate. V1 we have to take. First volume is what now? V1. And first temperature is what? T1. So V1, T1 given. And P1 is what now here? P1 is 1 atm. P1 is 1 atm. And volume V2 we have to calculate. Temperature T2 is equal to 127 plus 273. And what they gave condition, if the pressure is kept constant, that means what? The final pressure also what? Same. So P1 is equal to what? P2. So what is condition given here? So P1 is equal to P2. So P1, P2 both are same here. So P1 is equal to P2 means what is kept constant here? Pressure is kept constant. At constant pressure, the relationship between volume and temperature is called what? Charles law. So it is according to Charles law here. Charles law equation we have to apply here. So V1 is given, V2 is to be calculated, T1 is given, T2 is given. Now we have to convert the centigrade temperature into Kelvin temperature. So 127 degrees Celsius plus 273 will be equal to 400 Kelvin. So applying Charles law what here? V1 by T1 is equal to V2 by T2. V1 by T1 is equal to V2 by T2. Because V by T is equal to constant. V by 2 is equal to constant. Okay, that's why we have to take V1 by T1 is equal to V2 by T2. From this V2, we need to calculate here. V2 is equal to V1 T2 by T1. That is equal to 800 ml. So volume of the gas at final condition we can calculate. So this is according to what Charles law now here. First one, previous problem is based on Boyle's law. Second one is Charles law. Next, example 3. A gas cylinder containing cooking gas. Gas cylinder containing cooking gas. So cooking gas means LPG. Cooking gas means what, na? LPG. Remember that one. So can withstand a pressure of 14.9 atmospheres. How much pressure it can withstand? 14.9 pressure it can withstand. So maximum pressure, how much it can withstand? Maximum pressure it can withstand is what? 14.9 atmospheres. How much it can withstand? Maximum 14.9. So the 14.9 is to be taken as what? 14.9 is to be taken as what? P2. P2 means what here? P2 means what here? Yeah, sorry, ma. So here, P2 is what now? 14.9 atm. And why we have taken P2 is equal to 14.9 atm here? Because the cooking gas is present in the cylinder. The cylinder maximum can withstand how much here? 14.9 atmospheres, right, ma? That's why this P2 should be taken. Maximum withstanding pressure is what? 14.9 we have taken here. Remember. Next, the pressure gauge of cylinder indicates 12 atm. Okay. Now, when you use some pressure meter, that will measure, suppose how much pressure is there inside the cylinder. But cylinder withstanding pressure, how much? 14.9. Maximum pressure, how much it can withstand, they said? 14.9 atm. But how much pressure is there inside the cylinder now? When we measured 12 atm. So this 12 atm should be taken as what? P1. P1 is taken 12 atm, but maximum withstanding pressure, how much? 14.9 atm. Okay, so this 12 atm was measured at what temperature? T1 temperature. T1 temperature, how much given here? 27 degrees Celsius is given. 27 plus 273, how much? 300 Kelvin. So we have to convert the centigrade temperature into Kelvin temperature. So P1 is 12 atm, T1 is 300 Kelvin. Okay, ma. Next, maximum withstanding pressure, how much? 14.9. Due to a sudden fire in the building, the temperature starts rising. The temperature of the building is increasing. At the same time, the temperature of cylinder also will be increasing. Na? At what temperature will the cylinder explode? So at what temperature means T2 we have to calculate. So T2 temperature we have to calculate here. Right, ma? So T2 temperature we have to calculate. But T1 is given how much? 27 degrees Celsius, that is 300 Kelvin. So P1 12 atm, T1 300 Kelvin. P2 withstanding pressure, how much? Maximum withstanding pressure of the cylinder? 14.9 atm. Then T2 at what temperature the cylinder will explode? That means at what temperature the gas in the cylinder will reach 14.9. We have to understand. When the pressure of the cylinder becomes just more than 14.9 atm, immediately the cylinder will explode. So temperature T2 we have to calculate. Now solution is what now here? Since the gas confined in a cylinder, as the gas is inside the cylinder, enclosed in the cylinder, its volume remains constant. Whenever they say some gas in the cylinder, immediately you take cylinder indicates what here? Constant volume system. Constant volume system, that is. Cylinder is nothing but a gas confined in a cylinder, means a gas enclosed in a cylinder. Gas stored in a cylinder means what? The volume remains constant. So the volume remains constant here. When volume is constant, the relationship between pressure and temperature, the relationship between pressure of the gas and temperature of the gas at constant volume is according to which law? Gay-Lussac's law. Gay-Lussac's law states that at constant volume, pressure is directly proportional to absolute temperature. When temperature increases, pressure also will increase. That's why here, when initially pressure is 12 atm, when you are increasing temperature by fire, what happens? The atmosphere 12 atm will be increasing, and it will reach at one point, at one temperature. The temperature will reach what? 14.9. Just above 14.9, the cylinder will explode. That temperature we have to calculate now. So applying pressure temperature law. What is pressure temperature law called? Gay-Lussac's law. This Gay-Lussac's law is also called Charles law 2. Charles law, Charles law 2, otherwise Gay-Lussac's law. Gay-Lussac's law. Or also we can say Amonton law. Amonton. 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 Amonton, Gay-Lussac, or Charles law 2. Anyone is same. That is pressure temperature law. So pressure is directly proportional to temperature when volume is constant. Now here, what is relation here? P1 by T1 is equal to P2 by T2. P1 by T1 is equal to P2 by T2. Okay, ma. So what we need to calculate here? T2 we have to calculate. At what temperature the cylinder will explode, they asked. T2. T2 is equal to P2 T1 by P1. When we apply the values here, we get 372.5 degrees, means 372.5 Kelvin it is. We got in absolute scale here. But suppose if answer is given in centigrade again, this Kelvin temperature we have to convert into centigrade temperature. How to convert Kelvin to centigrade? Minus 273 we have to do. So 372.5 minus 273. So we have to subtract what? 273 from this Kelvin temperature. When you subtract what we get? 99.5 degrees Celsius. But in the formula directly T1 value should not take in centigrade. Remember, T1 value should not be taken directly in centigrade temperature. We have to convert always given centigrade temperature in the problem into Kelvin. Then only we have to calculate. After that, finally we get temperature in Kelvin again. From this Kelvin temperature, we have to subtract 270 to get degrees Celsius. Okay, ma'am. Next, another problem. A 1000 ml sample of a gas at minus 73 degrees Celsius. A 1000 ml is what here? V1. What is this given, ma'am? So it is V1. Suppose V1 volume of the sample of gas at minus 273. That is T1. How to get capital T1 here? This given centigrade temperature plus 273. Centigrade temperature plus 273, na? So minus 73 degrees Celsius plus 273 will be equal to 200 Kelvin. That's why a temperature T1 is given, taken what now here? Temperature T1 is equal to the given centigrade temperature plus 273. So minus 73 plus 273 is equal to 200 Kelvin. So it is T1 temperature taken. And V1 how much is given to you? 1000 ml is given. And what is given? 2 atmospheres pressure. The pressure is what initially given, what? P1. So this 2 is what now? 2 atmosphere is what now here? P1. So P1 is given what? 2 atmospheres. T1 is given 200 Kelvin. V1 is given 1000 ml. So this gas is heated up to 123 degrees Celsius. So what is this given here? T2 given here. T2 given in centigrade or Kelvin? T2 value given in centigrade temperature. Again, we have to convert into Kelvin temperature. So 123 plus 273. So T2 will be equal to 123 plus 273. That is equal to 400 Kelvin. So T2 value we have calculated as 400 Kelvin. T1 how much? 200 Kelvin. And the pressure is reduced to 0.5 atm. So the 0.5 atm is what now? P2. So initially P1 how much was given? 2 atm. Initially P1 was given 2 atm. The P1 is reduced to 0.5. That means what is this here? 0.5 is what? P2 given. What will be the total, the final volume? What will be the final volume of the gas? What is asked here to calculate? V2 is equal to what? Okay, V2 we have to calculate. So V2 we have to calculate. So what are the given conditions here? P1, T1, V1 given. P2 and T2 given. P2 and T2 given. We are asked to calculate what? V2. Okay, ma. So initial conditions what given? P1 pressure, initial pressure is given 2 atm. Initial volume is given 1000 ml. Initial temperature is given 200 Kelvin. And final pressure is what now? 0.5 atm. I told you here, to and by concept. If they say reduce it to 0.5, the P2 should be taken 0.5. Okay, suppose if they say the pressure is reduced by, by, suppose Pressure is reduced by, if they say, suppose. Then 2 minus, initial minus 0.5. Initial 2 minus 0.5 will be equal to what now? 1.5 atm will be taken as P2 in that case. But here by is given, 2 is given here. Reduced 2 or reduced by, reduced 2 given. So the pressure is reduced to 0.5. That means from 2, the pressure is reduced up to 0.5. So the final pressure is what now? 0.5 only we have taken. Okay. So V2 we need to calculate here. So what is the relation here? What is the formula? P1 V1 by T1 is equal to P2 V2 by T2. Okay. Now P1 V1 is equal to P2 V2 is what? Boyle's law. When temperature is constant, when T1 is equal to T2, suppose P1 V1 is equal to P2 V2. And V1 by T1 is equal to V2 by T2 is called Charles law. If P1 is equal to P2, if P1 is equal to P2 means when pressure is constant, V1 by T1 is equal to V2 by T2 we take. That is Charles law. Okay, so by combining Charles law and Boyle's law, we got equation what? P1 V1 by T1 is equal to P2 V2 by T2. So here P1 by T1 is equal to P2 by T2 is Gay-Lussac's law. P1 by T1 is equal to P2 by T2 when V1 is equal to V2 is Gay-Lussac's law. So by combining what now? Boyle's law, Charles law and Gay-Lussac's law, we have got a combined gas law equation. Combined gas law equation, that is P1 V1 by T1 is equal to P2 V2 by T2, initial conditions and final conditions. Then what we are asked to calculate here? We are asked to calculate V2 value. V2 is equal to this formula here. V2 is equal to what now here? V2 is equal to P1 V1 T2 by P2 T1. Like this, we got 8,000 ml. What we got? 8,000 ml is what? Final volume. Sometimes they give answer in liters here. So 8,000 ml is equal how many liters more? It will be equal to, okay, by 8 liters here. 8,000 ml is equal to 8 liters. So in this way, remaining problems also, you have to go through from any reference book. Any one reference book, you take it and go through that. Remaining problems based on ideal gas equation we'll discuss in the next class. Okay, ma.